Square roots are a topic that are closely related to exponents, and we'll see why as we talk about a few of these examples. In example 13, we want to find the square root of 25. In this case, that would be 5. We know that's the correct answer because 5 times 5 equals 25, which is the same thing as 5 squared. And square roots are just the inverse operation of exponents, or radicals, I should say, are the inverse operation of exponents. A square root is the inverse operation of squaring something. So to find the square root of a number, we just need to find a number multiplied by itself that gives us the number under that radical. Meaning that similarly, in example 14, if we want the square root of b squared, that would be b, because b times b equals b squared. So square root means find a value that multiplied by itself would give you the value that exists under the radical. We also can expand on that relationship between square roots or between radicals and exponents by establishing the rule that the square root of x is equal to x to the 1/2 power. Write that a little bit more clearly. So every radical can be written with an exponent notation. So we're not going to go into it much right now, but if we had, say, the third root of x, this would be the same thing as x to the 1/3 power. But for right now, we're really just focused on square roots, which, even though we don't write it, we kind of imply that there's a 2 above that radical symbol. We also have 2 additional rules that we want to establish: the product rule for simplifying square roots and the quotient rule. If we have 2 factors, so 2 values being multiplied together under a radical, then we can break that radical up into the product of 2 different expressions. We can break this up as the square root of a times the square root of b. And similarly for the quotient rule, we can split this up as the square root of a divided by the square root of b. And similar to our rules for exponents, we'll just need to know when it's better to put a problem in one form, the form on the left or the form on the right, whichever one helps us break down or simplify an expression better.